Alright, so here we are with Unit 9, Lesson 9, and we're going to look at neutralization reactions, and we kind of looked at these before. They are a type of double replacement reaction, and neutralization reactions in general have the same two products that form each time. And this would be sort of like a generic template for it. When you react an acid and a base, you're going to produce a salt and water. Now obviously the formula for water is never going to change, but the salt depends on which acid and which base that you use. So if you look down here, here's the acid. It begins with H, that's going to be an acid, and this has OH in it and not carbon, so it's a base. And what's going to happen is that the H from the acid and the OH from the base are going to join with each other and form water. The metal from the base joins with the nonmetal from the acid and forms the salt. So in this case, your salt would be NaCl. And on occasion, if they want to be really mean, they will give you the salt in the question, and they ask you what acid and base did you need in order to form that particular salt. It's not a question that you see a lot, but it can happen, so you need to be aware of that. I think you'd be fine with just knowing the basics of a neutralization reaction and the fact that it's a double replacement reaction. You just have to be careful when you're trying to figure out the formula for the salt that you have to make sure the positive and negative charges cancel out, right? Sodium's a +1 oxidation, chlorine's a -1, so they cancel out. That's why it's in a 1-to-1 ratio. It's not always going to be that way. If you look down here, we have something called the net ionic equation, and the net ionic equation really is leaving out something called spectator ions. Now, we haven't covered spectator ions yet, so I'm not really going to worry about this. Spectator ions is really something from the unit on oxidation and reduction, so you don't need to worry about this right now. We'll get back to that at some point. So let's take a look. We have a few. I'm not going to do all of these questions. I'm going to do a couple of them, and then if you have a question on them or the other ones that I didn't do, we can go over those. So again, this is a very simple one. So the H joins with the OH, and it doesn't matter if you write the water first or second. And then the K would join with the Br, and K is a +1, Br is a -1, so it would just be KBr. This one looks a little bit more tricky. All they did was put the base first and the acid, so the H and the OH will join, and I'm going to put the H2O here, just so that you don't think that the H2O always has to go first. And then I'm going to join the Na with the acetate ion. Sodium's a +1. The C2H3O2 ion is a -1, so that is going to cancel each other out. And these are the other two here. I'm not going to worry about well, I guess we have time, so let's just do this. I'm going to put H2O here, and then the K is going to join with the PO4, and this is where you got to be careful. It's going to be K3PO4. Now, why is that? Because PO4, if you look on in your reference tables, on table E, I think it is a -3 charge. K is a +1, so in order to cancel out the -3, you're going to need 3 positives, so that's why this form is K3PO4. And this one's going to be, again, the H2O. I'm just alternating where I write the H2O. And then you're going to get calcium is going to join with nitrate. And this gives you another example of where you have to be careful with these, because here's the formula for calcium nitrate. Calcium's a +2. And nitrate, the NO3, is a -1. So you need 2 of them. And that's why the formula is CaNO3 And that is, in essence, neutralization reactions. At the bottom here, this is not something they ask about on the Regents exam, so we are just going to cross it out. Not going to worry about that. And I think that is it for this lesson.